this video, we're going to come up with the rule for the derivative of a logarithmic function. So a general logarithmic function would be of this form: y equals log base b of x, and the restrictions you're going to put on that base are b can't be 1 and b has to be a positive number. Now, just like when we did the derivative of the exponential, there's one base, one value of b that turns out to be a little bit easier to get the derivative of, and it's the one that we use the most often. And it's the same one that we used for the base of an exponential, and that was e. So let b be equal to e, which if you remember we called Euler's number, which was approximately 2.718, etc. It was an irrational number, so it was infinite decimal. So that means that y is going to equal log base e of x. Now this logarithm ends up being so important, so useful, that we actually give it special notation. So instead of writing it in this form, log base e of x, we'll write it like this. We'll use the letters L, N, X. So that just means the same thing. And the reason that you use the letters L and N is this is referred to as the natural logarithm. So this is probably, especially in calculus, this is going to end up being the logarithm which you use the most. So we use it so often that we just give it special notation. Now sometimes you'll see people read this ln. Now that's not an official name. Officially this should be read the natural logarithm of x, but people will just often abbreviate it as ln x, which is kind of like reading cosine cos. Right? Like that's not what it means. You'll never hear or read in a textbook ln x, but sometimes just for shorthand, or just to say it quicker, you'll read it ln x, but officially the name is the natural logarithm of x. So now we're going to figure out the derivative of this. So the derivative of the natural logarithm. So the natural logarithm, y equals ln x. Remember that's y equals log base e of x. So the way we're going to come up with this derivative is we're going to write this in exponential form. So if you remember how to convert from logarithmic form to exponential form, this would be e to the power of y equals x. So these two things say the same thing. This is just in exponential form. And the reason we do this is we have a derivative rule for this exponent, e to the power of something. So we can just use that rule to come up with this derivative rule. So what we're going to do is implicitly differentiate. So we're going to differentiate with respect to x, both sides. So on the right side, that's easy. The derivative of x with respect to x is just 1. On this side, the derivative of e to the power of y, remember that rule was e to the power of y. It's itself, it's its own derivative. But then because we're differentiating a function of y with respect to x, we need to use the chain rule, which means you would put a dy by dx right there. And now we're looking for the rule for dy dx. We want to know what is dy by dx. So we'll isolate for dy dx, which would be 1 over e to the y. But we want this as a function of x, so we're just going to replace, remember, e to the y equals x. So we're just going to replace that e to the y with x. Okay, so that's the rule. The derivative of the natural logarithm of x, or ln x, is equal to 1 over x. So let's just write that down as a rule. So therefore, the derivative of ln x, or the natural logarithm of x, is 1 over x. Now there's one thing usually you should state, sometimes people forget to state it, and that's the domain of this thing. The domain is x must be a positive number. And the reason that x must be a positive number is that's the domain of ln x, or the natural logarithm of x. But if you just looked at the derivative, 1 over x, you might think that x can be a negative number, but of course it can't be. And that can sometimes be very important when doing derivative application questions, when you have to find slopes of tangents or points where a derivative is equal to a certain thing. You always have to keep this in mind, that x must be positive.